we've been talking a lot about speaking up. So let's do that today, really speaking up. There you go. You're thinking?
Yeah.
I saw you working with your geoboards, making designs. I want to remind you that, do you remember last week? And actually for the last 2 weeks, we've been working with fourths, eighths, halves. I want you right now to think about this. What is the relationship between a half and a fourth? Or what's the relationship between a half and an eighth? Can you talk to the person next to you? Get some ideas so we can put some of these on the board? Great. I heard lots of ideas. So, smaller pieces?
Because there's more of them. There's more of them, but 8/8 is equal to 4/4, and it's still 1 whole. So, but there are more 8/8s, so they have to.
Great. 8/8 is equal to.
4/4.
We came up with that.
Richard, can you explain that? Can you try?
Okay. Since 8/8 has like a lot of pieces, and 4/4 has less, so there would have to be like it has more pieces, so they would have to be small because there's so many of them, and that it's still equal to 4/4 because they equal to like the same thing, but there are more of them in eighths, so they would have to be smaller, so they could equal up to a whole.
They would have to be smaller. Can you be more specific?
The eighths would have to be smaller, so they could equal up to a whole.
Okay. How many eighths are you talking about? 1/8?
1/8?
1/8 is smaller?
Yeah. It's smaller than 1/4.
Do you agree?
Yes.
Okay. Can somebody restate or say in your own words what Richard discovered about this relationship between eighths and fourths? Eve?
That since there's more of like the eighths, so there's more. If there was 8 pieces of an 2 4s equals 8. Of course, there's more pieces, but if there's more pieces, the pieces have to be smaller. So 1/8 is smaller than 1/4.
Can I make something that has pieces? Can I make a pizza?
Okay.
You're saying, Eve, an eighth would be?
Would be smaller if everyone had an eighth of the pizza. It would be smaller than another class who everybody had a fourth of the pizza.
Okay, so I drew a pizza with 8 pieces and a pizza with 4 pieces.
And the pizza with 4 pieces, the pieces are tons bigger. It's like 2 pieces of, it's like 2 1/8 equal 1/4. 1/4.
2 eighths equals 1/4? 1/8, 2 eighths equals 1/4? Do you agree with that relationship between eighths and fourths?
Yes.
Okay, does anybody have a different idea about halves, fourths, eighths, and how they're related? Ben?
8/8 is a whole and 4/4 are a whole. So that's why you said they equal the same thing.
Okay.
And a fourth is half of 1/2. And an eighth is half of 1/4. And then a 16th is half of an eighth. And then it keeps going on and on. You double like the bottom number. I forget what that's called.
This number?
Yeah, like you keep
The
doubling
denominator.
that. Yeah, and it keeps being half of the next number.
Ben, can we write this down?
Yeah.
What's your rule for finding these fractions?
You split them in half, and then you double the double the denominator. if you split a fraction in half, the denominator will be doubled.
I don't know. I should be writing this higher, guys. Okay. Ben, can you carry on with this? What were you saying about? You were going pretty quickly, but I want to make sure that everybody can get this. Isaac here? I got a fourth is a half of a half.
Yeah.
An eighth is a half of a fourth.
Yeah. And then 16th is a half of an eighth. And then 32nd is a half of a 16th. And the 64th is half of a 32nd. And it goes on and on and on.
Okay. Can one more person share an idea about halves, fourths, and eighths? I'm sorry.
I think you should have a few kids.
Restate. Let's restate that, just to check in. Brittany, can you restate?
He said that 1/4 equals he said 1/4 equals 1/2, and 1/8 equals half of 1/4, and 1/16 equals half of 1/8, and then 1/32 equals half of 1/16, and then it goes on and on.
Okay. Can you say in your own words, how did Ben get there? How did he move from a fourth to an eighth? What did he do?
Because
Ben, some help? Let's get some help.
probably the doubles. When you double a number, it equals that number. And then when you use, like, for example, if 1/8 equals 1/2 of 1/4, 4 plus 4 equals 8.
Okay, Abby, take it away. How are we going to
Now-
divide this into halves, fourths, and eighths?
So you put one down the middle, stretch one across the middle, and then I just think, and then so the right side of that is the half.
Okay, you're going to call this the half.
Yeah, and then I go to the other side, and I put one. I put one down the middle, but the other way.
This way?
Yeah.
Horizontally?
Yeah. And then the top square, I'm gonna put it down. I'm gonna put it a rubber band down the middle the same way we just did.
Vertically or
Horizontally.
Horizontally? Horizontally?
Yeah.
Okay.
And the bottom part is the fourth, and then the top two parts are the eighth.
Can you be more specific? What is there a shape to this? The top
The
rectangles?
rectangle.
Okay. Are what?
Eighth.
Okay.
And that's the fourth, and that's the half.
How would you work sixteenths into this? Could we make this with sixteenths?
Yes, you can make it with 37.
Luca?
In the one of the eighths, you split one of the eighths in half.
Which one do you want to split?
The bottom one.
The bottom one.
And then for 30 seconds, you just split one
So wait,
of
can I stop for a second? What did you just establish here? What did you just make, Luca?
16ths.
16th here?
Yeah.
Mhm.
And for 30 seconds, you just make a triangle.
How would I do that?
You split the bottom. You split the bottom 16th diagonally.
Okay. Who can restate what our job is right now when we go off to work? Anna, would you?
When we go off, we're going to think as many designs as we can that split the geoboards into halves, fourths, and eighths, and maybe 16ths, and 32s, and so on.
Right, right. The job that I put out to was just this idea of using combinations of halves, fourths, and eighths. Obviously, people are thinking beyond that, and you're using this idea of splitting the halves by doubling the denominator. Folks, after you can work with a partner on this or individually. After you've come up with some ideas and you can prove them to your partner, don't come prove them to me. Prove them to your partner. Prove that there's a half in there, there's a fourth in there, there's maybe 2 eighths, and that they make a whole. After you've proven them and you're happy with your work and you're ready to record it onto a larger sheet, your favorite combination, then they're right up here. You'll come and get one. Okay, but you have to prove it first to a partner. All right? If your partner's trying to sneak away to get this paper and to record it, call them back and say, explain this to me. Prove to me that these parts, these combinations make a whole. Okay? We ready to go? Yes? Do you have a question, Abby? I'm sorry, guys. Hold on. Abby has a question.
I noticed something.
What did you notice, Abby?
That, like, it starts at 1/8, and then, it goes to 1/16, and 8 times 2 equals 16, and then it goes to 32, and 16 times 2 equals 32, and then 32 times 2 equals 64.
Abby, that's a really neat idea. The idea that you're actually doubling by, not 2, you're doubling the whole fraction by half, by 1/2. And we're gonna work more on that. Keep this idea. I want to write this down when you guys go off to work, this idea that you have. Okay, about how to keep splitting. All right? But Abby has I want to write a different idea about what Abby's coming up with, this idea of multiplying by 2, multiplying by 1/2 actually. Folks, we need just one representative from each work table to come take papers for your table, and let's get started.
Let's start here. If you look at this square and you divide it in half with this rubber band, would you say that these two shapes, these two rectangles, are equal? And are they half of this square?
Yeah.
All right. Now, this is definitely a half. Now here, is this a half? Are these two triangles equal? Is this triangle equal to this rectangle?
No.
And how could it be half if it's not equal?
Because they both have 1.5. Actually, yeah, they both have 2.
So now you think...
They are equal. It's because they have 2 halves, and that makes 2.
Okay, so now you think the triangle is equal to the rectangle? And could you prove it?
Yeah, it's got, one, say this is a square.
Say it's a square, so let's make it a square. You're saying this is a square right here? Like this? Okay.
And these are 2 halves of the square. These are 2 halves of the square. And if you put them together, they make 1 square, so it's equal.
So if I take this triangle and this triangle and I move this triangle over here,
The whole board is
like this, these 2 triangles are equal to these 2 triangles. Yes? And therefore, they would make this shape if I put them all together. Great proof. So now, if this is a half, what size is this? What fraction of the geoboard is this?
No, we already have this though. We already did this. Look.
Sure?
Sure.
Do you know what size of the geoboard the square is? What fraction of the geoboard the square is?
Oh, yeah. Well, we already did that. If it's whole, it's a 4.
Okay, so it's 1/4 of the whole
So it's
geoboard.
an 8.
So it's an 8. So what is this?
An 8.
An 8. Very good. what is this?
I'm trying to split it like diagonal.
Do you have any idea what size this is?
No, I'm trying to figure it out now.
Okay. So what size is this?
That's a half.
What is this?
That's a fourth.
And you can prove it.
Yeah.
And what size is this?
This is an 8.
And what size is this?
It's a 16.
And what size is this?
16.
And you're sure?
No, I'm finding it out.
How are you going to find it out?
I'm just trying ways to figure it out, like by counting the squares to see if they're even number.
By counting the squares? Where do you see the squares?
Well, like in a cube, from all the nails, there's squares.
Oh, you mean like here? This is one square right here? Like that?
Yeah.
Okay. So how does that help you with this triangle?
It helped. Well, I guess it wouldn't really help me
Why not?
because I don't know. It just wouldn't because it wouldn't help me figure out the fractions.
Did it help you figure out this triangle?
Yeah.
How does it help you figure out that triangle?
Well, I found out they were halves, so I did one, and then that's 2 if you add these two together.
So you could prove that this equaled 2 square units because these 2 triangles coming together made another one of these squares. And that gave you what size?
That gave me 2 squares.
Which is a half, a fourth, or an eighth?
An 8.
An eighth, okay.
And
So this is an eighth and this is an eighth, right?
and I started out with just half.
Uh-huh.
And so I added all these squares, and here's another square.
Uh-huh.
And these go together.
But this one's funny, isn't it? How are you going to think about that one?
I could split it in half like that, and then add them together.
And that proves that that's another square unit, okay?
And then I did the same thing on this side, and I found out that it was
Okay, so this side is even with this side. These are equal. These are both fourths. But I
Yeah.
loved what you were doing before. That was so interesting, and I wonder how you're going to prove it. Because you have proved that this equals this, and that they are both 4 units, right? So now you also proved before to me, I think. Can you prove that this? Yes, you did. You proved that this was 2 units, right? Or 1/8, because you said that these 2 together equal this, and it's 2 units, and that's 1/8. But then you put this very interesting line down here. So I'm really curious how you can prove that. Are these 2 triangles in fact equal?
I think it's 1/16.
You think it is? What size this is?
These are 1/16, but I'm going to cut it in half into a 32.
30 seconds. You have 2 30 seconds. And what size is this?
1/8.
And how can you prove that it's 1/8?
This hole is 16, and 1/8 of 16 is 2.
2 square units.
Yeah.
But this isn't square, so how do you know that it's 2?
This right here is 1 square, and these 2 16s together equal 1/8.
Okay.
I mean 1/16.
These 2 together make another square. So together it's 1/16. 2 squares, which is 1/8. What size is this?
1/4.
And how can you prove that?
Because there are 3 whole squares and 2 16ths. No, 2 32s equal 1/16, and that's 1 square, and that equals a 4.
Whoa, 2 30-seconds equals 1/16, and 1/16
Is a square.
is a square.
And then plus the other 3 squares is the fourth.
Wow, so the other 3 squares are also 16ths?
Yeah.
So you've added 1/16 to 3/16ths and 2 30-seconds, and you got a fourth.
Yeah.
You gotta write that down. Could you write that down? That's great. Okay, now can I show you something? You're writing this in a very interesting way, 3 1/16ths. But mathematicians would write that as 3 16ths. So if they would write this as 3 16ths, what do you think they would write 2 1/32 as?
30.
Exactly. And if they were going to write 7 64ths, what would they write that like?
7.
You got it.
Instead, he said keep splitting the fraction in half and doubling and double the denominator.
Uh-huh.
And what you're really doing is you're splitting. Like, see, let's say this.
Uh-huh.
This is a half.
Let her talk and then you can talk.
This is a half, and you split that in half,
Right?
and it's a fourth.
Uh-huh.
And then the fourth, you split that in half, and it's an eighth.
Uh-huh.
This is an eighth.
Right?
And then if you split that eight in half, it gets to 16.
And
And
then?
then the 16, split that in half, gets you to 30.
Very cool, right? So what you were saying before, or what people were saying before was, half of, of let's say 1/4 is 1/8, right?
Yeah.
And then you're saying two of these eighths, 2 times 8 is 16, right? Sorry.
So you're doing it 2 times the number. You're doubling.
You're either doubling or halving, however you're thinking about it.
Yeah.
So what is halving is the size of the piece, right? The
Yeah.
piece is getting cut in half.
Half and half and half.
And the number of pieces is
getting doubled.
doubling, right? If you could write that down, and you can share that tomorrow. So the number of pieces is doubling,
Yeah.
and the size of the piece is halving.